All right, this is the President's Day class. I want to talk for a little while. We've got two units coming up. One is about labor supply. We talked a bit about that. The other is about benefit cost analysis and human capital investments. I think what I'm going to do is leave the rest of the labor supply material to a week from today. And go through some preliminary parts of the benefit cost analysis. The Murnane book, I think, is pretty good in setting up benefit cost analysis. So I want to go through some of those kind of elementary parts of benefit cost analysis so that you'll be ready to go. In looking at actual benefit cost analyses, the Barnett reading is particularly beneficial. He kind of grinds through a benefit cost analysis for Perry Preschool. I think he does it at age 19, but he includes forecast of benefits into the future. We'll be able to look at what the future follow-ups hold and see how well those kind of forecasts held up. But the point is that there's this logic to benefit cost analysis that is one that economists, it works for both social investments as well as personal investments. So this kind of logic of compiling the benefits and costs and doing the discounting and so forth holds true regardless of whether you've got a societal perspective or a personal perspective. So let's start in. I've tried to set up an overview, and the three kind of vantage points for thinking about benefits and costs are for the individual. So this is even a Perry Preschool kind of program would have benefits and costs for the individual child and his or her family, potential benefits and costs for taxpayers. And it is the sum of these individual and taxpayer benefits and costs that are going to equal societal benefits and costs. So this cell is simply the sum of these two. And the idea is, in terms of thinking about the profitability of a social investment, resources are used up in making the investment. In the case of a Perry Preschool kind of investment, you are taking the time of teachers, you're using buildings. So there are real society resources that are being expended during that 1 or 2 year period for Perry Preschool. And that can be decomposed into the benefits and costs for the individual. Usually there's no cost in the case of Perry Preschool to the individual. So all of these society resources that you're expending are at the expense of the taxpayer, right? The taxpayer is putting up in a Perry Preschool, if it were a public program, all of the societal resources and the cost of those things are falling onto the taxpayers and not the individuals, not the kids or the families. Benefits, on the other hand, could easily come for individuals, they could come for taxpayers, and again, we just want to add these up to get societal totals. But think about again a preschool investment like Perry. You've got long-run benefits to the Perry kids because Perry Preschool really made a difference, and by the time they were in adulthood, they were earning more, right? And those higher earnings are a real benefit to those kids. On the other hand, they were also committing less crime, and taxpayers were incurring less cost for juvenile and adult criminal justice. So crime really isn't a benefit or a cost for the Perry kids, but it is a benefit or cost for the taxpayers. But whatever kind of benefits come out of this kind of calculation for the individual and the taxpayer, if you want to know about what the total social benefits are going to be, it's going to be the sum of the individual and taxpayer benefits. Similarly with costs. The investment costs we said are going to be incurred by taxpayers. In college investment, students themselves are incurring a cost. In particular, well, tuition cost is the most obvious, but there's an opportunity cost of spending time in college rather than going out in the labor market and earning money. There are taxpayer costs for, let's say, a college investment in the form of both the kind of expenses that are being incurred on behalf of college students that aren't part of tuition. Now, the state of California puts a lot of money every year into higher education. Some of that gets recouped by tuition, but a lot of it doesn't. So there are taxpayer costs for providing the University of California system that don't fall on the shoulders of the students. So it's the ones that do, plus everything else that's going to be this idea of a total social cost in this case. And the bottom line for whether any investment, either personal or social, is beneficial is to see whether the benefits end up exceeding the costs. And you can think of those from an individual point of view, from a taxpayer point of view, but we're going to try to focus on the societal point of view. It's a little bit annoying that a lot of times when government wants to know whether a program pays off, they want to know whether it pays off for taxpayers. But from a total society point of view, there's going to be a certain total benefit, and you don't really care from a society point of view whether the benefit goes to taxpayers, right, in the form of higher tax revenues from higher earnings or lower criminal costs, whether it falls on the taxpayers or resound to the taxpayers or the individual. That gets divided up somehow, but it's really the total benefit and cost that we're, you could argue that you want to take into a kind of policy debate to argue whether something is worthwhile or not. So a societal perspective is best. Taxpayer perspective is too narrow because it ignores the individual costs and benefits. But the idea here is we want this table, there are going to be real numbers in this table for any given investment. And every entry in this table is going to be some dollar value that is going to be the sum of all of the end period benefits or the end period costs that are incurred by by individuals or are beneficial to individuals. Same thing for taxpayers. Every entry is going to be expressed as a dollar amount in present value. This is taking into account the fact that dollars tomorrow are worth less than dollars today. We'll talk about that in a minute. But that present value is going to be whatever that cost or benefit was in the year in which the program started, plus the benefit or cost next year, discounted, plus the benefit or cost 2 years from now, discounted even more, all the way out to however n periods of benefits and costs you have. So every cell ends up being this kind of present value calculation. And the bottom line is really going to be whether the sum of the difference between benefits and costs is a positive number or a negative number. So this is really the key cell of the table, because it says, taking everything into account, doing all the discounting that you want to do, is the benefit that individuals and taxpayers receive from a particular investment worth the cost? Does it exceed the cost? So that's where we're going to end up. But let's first talk about discounting. Which is a very simple idea. Suppose I offer you now, 1 year from now, or 2 years from now, $1,000. All right, so you can either have $1,000 now, you can have $1,000 a year from now, or you can have $1,000 2 years from now. Most people, when given that choice, will say now, I want it now. And the kind of implicit logic is, well, one way of thinking about it is if I had the money now, I could put it in the savings account or put it in the stock market or buy cryptocurrency. And a year from now, think about a savings account, you'd have more than 1,000. You have more than 1,000 because of the interest that you received on that $1,000. So we really want to know what is $1,000 1 year from now worth today. And that's going to be the present value of $1,000 that is available one year from now. And one way to think about that is, let's call it X. So we want an amount X, which when added to the interest that you could earn on X over the course of a year, let's call, say the interest rate is R. So we want X plus whatever interest, if the interest rate is 3%, let's say, we're going to have X plus 3% of X equaling $1,000. In other words, X times 1 plus R equals $1,000. In other words, X equals 1,000 divided by 1 plus R. So the present value of $1,000 that's available a year from now, if the interest rate is R, is going to be $1,000 divided by 1 plus R. And if the interest rate is, say, 3%, then X is 9 70. If the interest rate is 6%, then X is 943. Right, so you're just dividing by a bigger and bigger number as the interest rate increases, because the amount of money that you could earn in interest increases. So that's pretty straightforward. We just divide this $1,000 by 1.03 or whatever, 1 plus the interest rate. What about $1,000 2 years from now? In other words, what about that amount? What's the present value of $1,000 that's not available until 2 years from now? Well, let's call it Y. And now we want to know what amount of money today, which when added to the interest that we can earn in the first year, that's what we had before, but now we want to add the interest that we can earn in the second year. And the interest that we can earn in the second year is going to be the interest times the amount of money that's available at the beginning of the second year, which is just going to be Y plus RY. So we've got Y, we've got the interest that we earn in the first year, and then we have the interest that we earn in the second year. And if you just work that out, you're going to end up with Y times 1 plus R squared equaling $1,000. So Y, which is the present value of $1,000 2 years from now, is going to be $1,000 discounted by 1 plus R squared. Right? You could keep going. 3 years from now, Z, RZ, R, Y plus RY, or Z plus RZ. And then you've got this third year of interest, where everything that you bring into the third year earns the interest rate. And if you calculate that out, you're going to get 1,000 divided by 1 plus R cubed, and so forth, right? So that's where we get the present value formula, which is going to be $1,000 divided by 1 plus R to whatever the number of years out until it's available, where N indicates the number of years you wait to get the $1,000. And that works if you've got a stream of benefits. It works if you've got a stream of costs. So it's a very general, useful kind of discounting formula. Now, one potential problem is that it's hard, especially when inflation is not extremely low. It's hard to know what those future benefits are going to be because you know what the inflation rate is. But you can show that because inflation not only inflates these dollar values, it also increases the interest rate. Those two things pretty much cancel each other out. So think about it. Every time you start out with interest rate of 3% and you know that there's going to be 10% inflation, no one is going to still go with a 3% rate of return. They're going to want a 3% real rate of return, in other words, inflation adjusted rate of return. So they're going to be wanting something like a 13% return, not just a 3% return. So you can think about some future amount as being inflated by, let's say, the inflation rate is G. So all these $1,000 are going to be inflated by 1 plus 1 if it's a 10% inflation rate. And the further they go out, the more inflation there's going to be. But at the same time, we're going to have an inflation factor for the interest rate. And you get this approximation that those two things cancel out. So if you think about your stream of costs and benefits in terms of today's dollars, then you can go with an interest rate that is an inflation adjusted interest rate. And inflation adjusted interest rate R for safe, in other words, non-risky investments is about 3% historically. So that's the interest rate we'll typically use when people actually do cost benefit analyses. They plug in, and this is one of the things that Steve Barnett does. He'll plug in other interest rates to see how robust the conclusion that benefits exceed costs for CARI are. So that's kind of a standard robustness check. But it avoids a lot of problems in forecasting future dollar amounts to express all those future amounts in today's dollars, purchasing value of today's dollars. And then have a real interest rate of around 3%. Then you don't have to forecast what inflation is going to do to the interest rate either. But if you look historically at the difference between the rate of inflation and what's called the nominal interest rate is, the kind of going interest rate, you'll see that the difference is always about 3%. So in the past couple of years, inflation has obviously reared its ugly head, but you see interest rates increasing also, right? The amount that you have to pay to get a mortgage is quite a bit higher than it was a couple of years ago. It didn't increase so much that it reflected the 8% or 9% inflation rate that was in place a couple of years ago, but it definitely increased, right? And historically, if you do the kind of calculation, you end up with this difference between the nominal kind of going interest rate and the real interest rate of about the nominal rate minus the rate of inflation, it's going to be about 3%. Okay, so we're getting some tools here. So now let's apply them to an investment example. So let's suppose we've got some investment stream. That period 0, period 1, period 2, we just have a 3-period investment horizon here. Let's say the cost is $1,000. There's no benefit in period 0. There's no cost in periods 1 or 2. But after you incur that cost, you receive 2 periods of benefits of $600 a piece. Is this a profitable investment? And the answer to that question is, well, it depends on what the interest rate is. You know, if the interest rate's 0, there's no discounting, right? So this 600 stays 600 because it's not going to be discounted at all. And this 600 that's not available until 2 years from now is going to stay at 600 as well if there's no discounting. So if you think about net benefits, benefit minus costs, the benefits are going to be $1,200 minus $1,000 cost. So benefits are going to exceed the cost at a 0 interest rate. But a 0 interest rate isn't very helpful here because we really need to know what the discounted net benefit is going to be. And if you think about present value PV of net benefits in our kind of generic formula way, benefits minus cost in each period. In period 0, we're going to have a 0 benefit minus 1,000 in cost. So the net benefit in period 0 is minus 1,000. And we're going to add to that a $600 net benefit, 600 minus 0, but it's going to be discounted by 1 plus R because it's not available until a year from now. And then similarly in the second period, 600 over 1 plus R squared. And if we had benefits extending out in the future, we keep increasing this exponent by 1 for every additional year. So whether this is positive or not is going to depend upon the interest rate. And if you plug in some numbers, if R equals, well, 0, we already did 0, 3%, 6%, 10%, 20%. Present value of net benefits B minus, it's really the present value of net benefits is B0 minus C0 plus B1 minus C1 discounted plus B2 minus C2 discounted even more. So if you actually do those calculations with minus 1,000, discounted 600, double discounted 600, we know that if the interest rate is 0, we just get 1,000 plus 600 plus 600. In other words, plus $200. Oops. Plus $200. And if you continue with 3%, then it's going to be minus 1,000 plus 600 divided by 1.03 plus 600 divided by 1.03 squared, which is going to be plus $147. So you can think about this in a graphical kind of way. We've got period 0, period 1, period 2, minus 1,000, plus 1,000. So we know that in the first period, we've got $1,000 of cost. And then I wish I had green. I think this works very well. Oh, I guess it does. All right. So $600. We're going to have a $600 benefit a year from now and a $600 benefit 2 years from now. And it will look like that if the interest rate is 0. But the more the interest rate becomes positive, you can really think of a positive interest rate as shaving off some of this future benefit because of the discounting. So we really want to know how high does the interest rate have to be for this amount being shaved off to bring this block of 2 years of benefits down to $1,000. And at 3%, we still have these two blocks having an area that's bigger than that block. At 6%, it's the same thing. We've got $99 of net benefits. Even at 10%, we've got a plus $40. But by the time that interest rate gets to 20%, we're in the hole. So it's going to take an interest rate of somewhere between 10% and 20% to bring this block down to such a small area that it falls, it is less than the $1,000 block. All right, so at this point I'd ask any questions, but you're not here. So let me provide yet another perspective on this same investment. This turns out to be very useful. I think there's a problem set problem on this for next week. You can think of the present value of an investment versus the interest rate. Okay, so we've done 5%, 10%, 20%, oops, 15%. and 20%. And now we can plot the present value. 100, 200, 300, minus 100. Right, we want to allow some negativity on the y-axis here if the interest rate gets high enough. If you actually plot these things out, right, interest rate is 0. We've got a $200 present value. At 3%, we're at $147. About there. 6%, we're at $99. At 10%, we're at $40. And up at 20%, we're down to minus $84. Okay, and this will be on a line. All right, so didn't quite get my graph right, but pretend they all fall in a line. And this is showing you the present value as a function of the interest rate. And what it shows, this crossing point is about if I were drawing this correctly, it's about 13%. Right, that's the point at which this present value drops to 0. And what you know from this, right, if the decision rule is if an investment provides a positive net benefit when all the discounting is taken into account, then go with it, right? That should be true for an individual decision as well as a societal decision. But if it's negative, then it's not worth the investment. So this crossing point is very useful for making decisions. Let's say it is 13%, then you just know as long as the interest rate is less than 13%, you've got a profitable investment, and if it's more than 13%, you don't. This crossing point is called the internal rate of return. And it is the internal rate of return is the interest rate such that the present value of an investment is 0. Internal rate of return is the interest rate such that the present value of an investment equals 0. So in this case, as long as the interest rate was below 13%, present value is positive, the 13% changed. So 13% is the interest rate that makes this stream of net benefits equal to 0. So it's the finding an R such that the sum of net benefits, the present value of net benefits, is 0. So this kind of net benefit in dollars and internal rates of return are almost flip sides of the same coin. They both indicate profitability for a given investment. And when we gather in class, we'll talk about how it's not. Internal rate of return can be deceptive, but the present value of net benefits always gives you the right answer. So we'll show why that is true in class when we meet again. And just a final word about where we're going with this. This was a fake example, but we can apply it to Perry Preschool, or we can apply it as David Otter does to the question, what is the internal rate of return / net present value of a 4-year college degree? So that's an important calculation. If I'm personally going to try to decide whether I want to invest my time and energy in a 4-year college degree, sacrificing my the earnings that I could be gathering, paying the tuition and so forth, I would like to be reassured that that's going to be a profitable investment, right? And one can look to see in current population survey data whether on average that seems to be the case. There's always this selection bias that's potentially worrisome when you just compare existing workers who have college degrees and existing workers who just have high school degrees, because there's obviously some selection into who goes to college. But there are various ways of taking care of that, making adjustments for that. But the principle is that you want to end up with an unbiased estimate of what the return to college is. Individuals want to know that, but society wants to know that too, right? So if I'm in Congress wondering whether I should put more money into Pell Grants, I want to know whether providing money that will enable students to go to college is going to be profitable for society, right? So we want to be able to think about this college investment both from a point of view of individuals as well as society as a whole. And we'll do that when we meet again a week from President's Day.